So in this video, you're going to be learning how to solve comparative advantage problems, and along the way also absolute advantage. So the very first step in solving comparative advantage problems is to diagnose or determine whether or not it's an input problem or an output problem. And then depending on that, you're either going to follow the rule input into or output over to calculate the opportunity cost. So when we did absolute advantage is determined when you're just better than another country or another person in absolute terms. So if it's an output problem, um, let's say we give you an hour of input, an hour of time, and in that hour you can make 10 wagons and I can only make 5. You would have absolute advantage because you can produce more wagons than I can in 1 hour of labor. If we are talking about input, if we turned that question around and said, okay, well, how many hours does it take you to make one wagon, or how many hours does it take me to make one wagon? Let's say it takes you an hour to make a wagon, it takes me 3 hours to make a wagon. Again, you would have absolute advantage because it takes you less input to produce the wagon 1 hour compared to the 3 hours for me. So when it comes to absolute advantage, if it's an output problem, bigger is better. You're producing more with the same quantity of input, 1 hour of labor time. If it's an input problem, absolute advantage goes to whoever's input is lower, right? It takes you less time to make a wagon than it takes me to make the wagon. Comparative advantage, on the other hand, is based on your own opportunity cost. What do you have to give up in order to produce the good or service? And again, it's used as a basis for specialization in trade to achieve the gains that we get from specialization in trade. Now, if we're trying to decide what type of problem it is, it's an input problem if in the framing of the question it states the amount of the input. Like again, you've got 3 hours to make a wagon, and another person only takes 1 hour to make one wagon. How much labor, how much land was needed to get some specific quantity of output, one wagon. 3 hours, 4 hours, 1 hour, how many hours of labor, how many acres of land to get that wagon or to get a bushel of apples. An output problem, on the other hand, the quantities or the numbers in the question are representing how much output you get from a certain quantity of the input. So it might be, the number of wagons you can produce in one day, the number of wagons that you can produce in 1 hour. Okay, so that's how we're going to diagnose whether it's an input or output problem. So now this would be an example of an input problem. At the top we see it says robots and pizza, hours of labor to make one. In other words, how much labor time, how much of a labor input in order to produce one robot or one pizza. So that's a specific quantity of an output. So the numbers here, we've got two people, Woody and Buzz, and Woody requires 20 hours to make one robot, 5 hours to make a pizza. Buzz, 10 hours to make a robot, 2 hours to make a pizza. So who has absolute advantage? Because it's an input problem, whoever takes less labor to make the robot or to make the pizza has absolute advantage. So we see that Buzz only takes 10 hours to build the robot to Woody's 20. So Buzz would have absolute advantage for making the robots. Buzz also has absolute advantage for making the pizzas because he can produce the pizza with 2 hours of labor. Woody requires 5 hours of labor. So once again, because Buzz uses less labor, he has absolute advantage. So Buzz actually has absolute advantage in both things, making robots and pizza. But the point of comparative advantage is to say that even when you have an absolute advantage in all things, you will still gain by specializing in trading. But what basis do you use? You use your opportunity cost. Now, because it's an input problem, when we calculate the opportunity cost, we are going to put this number into, so like I want to calculate the opportunity cost for Woody of making a robot. So I'm going to take the 5 hours to make the pizza and divide it into the 20 hours to make the robot. 20 divided by 5 is 4. So every time Woody makes a robot, he gives up the opportunity to make 4 pizzas. The opportunity cost for the pizza is always going to be the reciprocal. I'm going to take the 20 into the 5 because I want to know the opportunity cost of the pizza. So now 5 divided by the 20 is equal to 1/4. Every time Woody makes a pizza, he gives up 1/4 of a robot. Now I simply do the same thing for Buzz. If I want to know Buzz's opportunity cost for making a robot, I take the 2 hours for a pizza divided into the 10 to make a robot, which is 5. So Buzz gives up 5 pizza every time he makes a robot. And the 10 into the 2 tells me that his opportunity cost of making the pizza is 1/5. 2 divided by 10 is 1/5. Now we just compare the opportunity costs for each thing. Notice I always put the people, I like to put the people for the rows and then, whatever good or service it might be as the columns. So I compare who gives up less to make robots. Well, Woody only has to give up 4 pizzas to make a robot. Buzz must give up 5 because Woody's opportunity cost is lower. We say that Woody has comparative advantage, and that's what he should specialize in. He should specialize in producing robots. Buzz, on the other hand, has comparative advantage in making the pizzas. He gives up only 1/5 of a robot. Woody would give up 1/4 because 1/5 is smaller than 1/4. That's where Buzz's comparative advantage lies, and he should specialize according to that comparative advantage. So Buzz should specialize in pizzas.